Let's begin with the definition of a polynomial. A polynomial in the variable x is an expression containing the sum of a finite number of terms of the form ax to the n power, where a is a real number called the coefficient, and n is a non-negative integer called the degree of the term. Examples of polynomials: 8x, 1/3 x minus 4, and x squared minus 2x plus 1. We see that all of the powers on the variables are non-negative integers being 0, 1, 2, 3, etc. Things which are not polynomials: 4 times x to the 1/2 is not an integer. 3x squared plus 4x to the -1 is not a non-negative integer. And 4 plus 1 over x. 1 over x, we've got a variable in the denominator, so variables to the negative exponents, variables to fractional exponents, and variables in the denominator make things not polynomials. Identifying terms. So a term in an expression is something of the form a times x to the n power. The number a is called the coefficient. The non-negative integer n is called the degree of the term. Polynomials use the operation of addition to put the terms together. If we consider the polynomial 3x to the 4th minus 2x squared plus 7x minus 1, if we were to pick out the terms in this particular polynomial, so the first term, 3x to the 4th power, and a negative 2x squared. So notice that we've got the operation of subtraction, but the key to this is that polynomials use the operation of addition to put things together, so that whenever we have a subtraction sign, that really means that the coefficient of the term directly following it is a negative number. So we've got a term of negative 2x squared. We've got a term of 7x, and we've got a term of negative 1. Again, we've got the subtraction sign, which means that the coefficient on that term is negative. So we've got a negative 1 for the term. Now let's discuss some of the terms that we will use when we talk about polynomials. A monomial is a polynomial with only one term. Mon meaning one. A binomial is a polynomial with two terms. A trinomial is a polynomial with three terms. When we talk about the degree of a polynomial, it's the largest exponent which appears on any of the terms. The leading term is the term with the largest exponent. And finally, the constant term is the term which doesn't have a variable. Adding polynomials. So the fundamental idea that we're talking about when adding polynomials is really nothing more than combining like terms. By like terms, we mean variables that are to the same power. For example, suppose we wanted to add 3x squared plus 7x plus 2. And then we wanted to add to that 5x squared plus 8x plus 1. In this case, we have three sets of like terms. The 3x squared and the 5x squared are like terms. 7x and 8x are like terms. And 2 and 1 are like terms. Now let's continue with our example. Suppose we were adding 3x squared plus 7x plus 2 to 5x squared plus 8x plus 1. If we group the common terms together, we put the 3x squared together with the 5x squared, the 7x and the 8x, and then finally the 2 and the 1. So then in the first two terms, we've got an x squared and an x squared. We can pull that out. An x, 7x plus an 8x. We can pull that x out. And then a 2 plus a 1. So your question would be, what property was used in the last step? In going from this step to this step, what property was actually used? So that finally, when we combine the 3 plus the 5, we get 8 times x squared. Combining the 7 and the 8, we get plus 15x. And then finally, combining the 2 and the 1 gives us plus 3. Subtracting polynomials. Subtracting polynomials is exactly the same as adding polynomials in that we just combine like terms. But you have to be careful in distributing negatives if you are subtracting a polynomial which is not just a monomial. Suppose we are subtracting 2x squared minus 5x plus 2 from 3x squared plus 7x plus 1. We have to remember to distribute the negative across all the terms in the second polynomial. All the signs of the terms in the polynomial that we're subtracting change. So as we distribute the negative, we have, instead of plus 2x squared, we have a minus 2x squared. Instead of a minus 5x, we have a plus 5x. Instead of a plus 2, we have a minus 2. Continuing with this example, now we are free to combine like terms. So we have a plus 3x squared minus a 2x squared. We have a plus 7x and a plus 5x. We have a plus 1 and a negative 2. So that when we combine those things, 3 minus 2 gives us 1 times x squared. 7x plus 5x gives us 7 plus 5 is 12 times x. And then finally, 1 minus 2 gives us minus 1. So that our final answer becomes x squared plus 12x minus 1. Now, for the next example, suppose we were going to subtract negative 4a squared minus 3 from the polynomial minus a squared plus 3a plus 12. Remembering to distribute the negative across the second polynomial, we have minus a squared plus 3a plus 12. The signs change in the second polynomial, so we have a plus 4a squared and a plus 3. So that our like terms, minus a squared and 4a squared, 12 and 3, while minus 1 plus 4 is plus 3 times a squared, 3a, and then 12 plus 3 gives us 15.